this 9th lecture on Fortran programming. Today we shall describe what is meant by Fortran function. There are two types of Fortran function. One is called the user defined function, or one is called the inbuilt function or the library function. Examples are sin x, log x, exponential x. That means these functions has already been done and installed. If you just call y is equal to sine of x, if x was known previously, then y is the value of sine of x provided x is given in radian. Such functions are already there within the Fortran, but sometimes we need to do some function which is not inbuilt, but we will require them. As for example, these are called user defined function. As for example, let us consider that we supply x and we need to calculate mod x. Although there is already an inbuilt function there which calculates y. If we write y, then it is abs of x gives you basically y is equal to mod x. But for the time being, as an example, we consider that we are not going to use this function and we want to calculate y mod of x provided the value of x. In an earlier class, we performed a program whose aim was to read from the terminal the value of x and to give you the output as absolute value of x. Here we will do the same program in a different way. That is, first the program will take x as input from the terminal, and then he will deliver the job to someone or something who will intake x as input and will return the value of mod x. Though this is the main objective of the program. And let me first do the program, write the program, and then I will explain to you. I am considering very simple example. So read x y is equal to ab of x then function blank the name of the function, which is ab, and the input need not be x. Then we write if z is greater than equal to 0.0, ab is equal to z. If z is greater than equal to 0.0, then ab is equal to z, else ab is equal to minus z, Now let me explain the operating of the function. Say you are giving the value of x, say x is equal to 5, then y is equal to ab of x. there is no dimension declaration in the program, so AB is not a dimension variable. So what is this? It assumes that it is an user defined function. AB is an user defined function. User defined function. X is its argument or input, and the output is AB itself. The function name itself is the output. So how does the program flows? Once X value has been inputted, right from there program jumps to function this AB, and it is z is equal to 5, because we have taken the example that x is equal to 5, so it is 5.0, and from here the program jumps to this line function AB with z is equal to 0.5, and then it this if loop, it calculates this AB is equal to 5.0, and then the program comes to there. Here is a new word, return. In main program we have used stuff. Here we use the return. That means this value of AB 0.5 will be returned to the calling destination. That is to say, as if this AB within bracket x will be wiped off and 5.0 will be there. That is to say, AB of x will be replaced by 5.0. So y assumes the value 5.0. If the value of x was -9, then from this line program jumps to there, and upon this query it comes to there, and it calculates AB as 9 and then returns the value of AB as 9.0 to the calling destination. Now you see first thing, the output variable in the case of Fortran subprogram is the name of the function itself. There is a big restriction. As the output variable is defined by the name of the function, then the output number is restricted to 1. But there is no restriction of inputs, so number of outputs is, in Fortran subfunction, the number of output is equal to 1. No restriction on number of inputs. Inputs may be 1, 2, anything, any finite number. I am considering a next program, a subprogram which utilizes 2 input and gives you 1 output. Another very interesting program would be giving you as homework, you know the temperature in centigrade, then make it programmed so that the centigrade temperature will be converted into Fahrenheit and vice versa. Now we are considering the example, a function which you have 2 inputs and 1 output. That is, we have a point in 2-dimensional Cartesian coordinates. The coordinates are the x and y, and we are to calculate r, the distance of the point from the origin. So the program is to calculate the distance of a point in 2D Cartesian coordinates, whose Cartesian coordinates are given. To find the distance of a point in 2D whose Cartesian coordinates, that is x and y, are known. So we write program read star comma star x and y as the input. Then we call the function r is equal to the name of the function. The name of the function is polar r. We give you polar r whose inputs is x and y, and then we write x and y as input and r as output. Without going to introducing r, we could also write prx comma y over there. In that case, this line is not at all needed. This will do. And then stop end. This is the main program. This is program main. Subfunction, then you write function, the blank, then the name of the function, PR, inputs x and y. I may write it x and y, or you may write anything, any real variable, say u and v will do. Then we come to PR. PR is equal to square root if one puts stop here, then what will happen? The program will calculate the value of r, but it will stop over here. At the first time, on the first time when you call this, the program will stop there. It will write xy and then it will be terminated because it is stop. We have used stop there. If we use return, then it will replace this by the value of r, But if we want to calculate the theta together in this program theta, then function will not do, because in Fortran a function has only one output. If you want to know the theta, then you have to make another program which will calculate the theta. In such situation, subroutine is very much useful. In a subroutine, there is no restriction on the number of inputs as well as on the number of outputs. But in Fortran subprogram, the output must be a single quantity. Let me do some more involved problem. Say we are supplied with a set of data, and we want to calculate the average of them. So we first write in the main program dimension blank. Say the quantity is real quantity x is 100, then read, we are using implicit do loop. So the when execution, first x1, then follow with the gap x2, the data are to be supplied along a row. Then we want to calculate the average. Sorry, AB x. Since x is a dimension variable, it will assume a string of values of x, and we can write first the x values, now come to the function. This is AV is a function, so we write function you may write x. Since x is a dimension variable in the main program, here we must also write x. If we put these two numbers different, the program will give you warning, and it's a serious error because the string must be the same over here as well as over here. Then one more thing has to be supplied in the function, that is a number of data. This is number of data, and x. Then we need to, so by this statement, all the values, say n is equal to 50, then all the 50 values has come to their first 50 values are the value that you have supplied, and next 50 values are 0. Then we do the sum. S is equal to 0.0, do blank 5 blank, I is equal to 1 to n, S is equal to S plus xi in between 2 to 5 column, continue. Then we have to calculate AV. AV is equal to sum divided by float, and AV has been calculated, then return end. It is customary to keep the length of the string same in the main program as well as in the subprogram. It is a customary, but the variable name may be anything. Here the variable is a real variable, so you can use any real variable. Instead of this line, the function can be written as z. Then here z100, variable name, here z, it is z, it's okay, z is again a real variable, and then we do sum is equal to 0.0, do blank 99 blank k is equal to 1 to m, s is equal to s plus z k, 99 continue. It is uncustomary. Then return end. So this is a very neat way of writing the program. One reads end data. In this line it reads. Then it calls a daemon. I use the word daemon. In Bengali means bhut or daitya, who engulfs the value of n, the number of data, and the data, n data. Then it returns to his master the value of the average value of x, and writes the value of x and x. This is the function of the daemon. In that case, the variable used may be different as in main program or in subprogram, but the sequence must be the same. First an integer, then the real variable, and here should be this. If we interchange this, then the program will give you wrong result, or in this case will not work at all, because the first argument is an integer and second one as a real array. If we interchange, the program will not be compiled at all, and it calculates the average value of the program. This can be used repeatedly. If we have a large number of data, then we can just change these three lines or this much. If we have a large number of data, then we can put this within another do loop, and the rest of you do not require to do anything. As for example, I say that there are 5 such data. 5 such data means first n1 is equal to 5, n2 is equal to 9, n3, let us take this example, 4. So there are n data, n is 3. So what we need to change this within this first read n, this is 3, then read n1, n2, n3. You can do it in this way, or you can define n is again within an array. I am not going to there because it will create complication. Then we do blank, say n, do blank 20 blank, I use 5 to a blank, n is equal to 1 to an n. This now we write this, read there will be a problem. So to overcome this, Then what we do? AV or we may even do not write N1 AV N1 X and if then if n equal to, then again the repetition of these three lines and n3, and this you see that you can use a lots of data, lots of sets of data and calculate the average by this single line, because entire burden has been taken by over here. Even another better way of doing this program is this. So I am using the same program and you changing the main programs. We say we may deal with at most 10 data. In 10, and in each set there will be less than 100 data. Read NN, the number. Then as for example, NN was 9 there. NN was 3 in the example we are considering. Read in the first case, nm is equal to 1, so it will go from 1 to n1, that we have done explicitly. In the second case, nm is 2, so it will run from 1 to n2, so this has been done automatically. And then we write value of nm, means which number of data we are considering, then n of nm and av of one thing I write nd, just write here line nd, in that nd is equal to n of nm and av ndx. 5 continue. Stop end. Here in this subprogram, the first one, n, is a dimensionless variable. Actually, what I am going to write is n of nm. In that case, n would be a dimensionless variable and a conflict will be created. That has been avoided by introducing nd, a dimensionless quantity. So you need not to change this program. So this program can calculate the average of at most 10 data, where each of the set contains at most 100 data. If the number, any one of the number is higher than specified in this, we just increase the number accordingly and the program will do. This is the use of subprogram. The entire program is a very simple one and the subprogram is a very simple one. This is just as like you see in the big fab companies gives order to the smaller companies to manufacture a part of their product, and then they collect these parts and assemble to get the result. It is like this. This is a bigger company whose aim is to calculate average of a large number of data. It has given a contract to a small factory to calculate the average when the number of data and the corresponding data are supplied. So once this company is asked with number of data, say n1, then it will just return the average value of n1 data. When you call it with n2, it will give you back the average of n2 data, and so on and so forth. One thing I have again written deliberately, the number statement number 5. In an earlier class, when introducing the statement number, we reminded you or warned you that in a program there will be no line having the same statement number. Still, I have used the same statement number here. This statement number is within the main program and this is in the subprogram. Within subprogram, you should not have two lines having the same statement number, as well as in the main program, you should not have two lines having the same statement numbers. Another example I am considering is that if we are supplied with a number of data and you are to calculate the either maxima or minima of the data. So the program works like this. Dimension say x 200 in number of data then we want to the large, so we write it assumes that there is a user-defined function named largest. Now come to the definition. Be careful about the spelling. I am making a deliberate mistake. Wow. Then the output has to be defined. The output is largest I suggest you to stop the video right at that moment and try to trace out the errors that has been there in the program. There are two errors. You think of yourself for some time and then again switch on the video so that you can get the answer to the problems. Firstly, the program starts with the name L, so the maximum number must be an integer. This is one part. So since we are dealing with real number, it would be better to put a R over here and R over here. So we write this. This is one mistake or error. Another is here the dimension is 200, here the dimension is 100. So either it has to be made 100 or this to be changed to 200. In the next class, we shall come with few more examples on functions.